Good morning, everybody. I am going to demonstrate the different sorting algorithms here using some cards and then some numbers. I did cut out that number sheet that was in your packet. I know there's 100 numbers, so cut it out and then you can try along with me. Why don't you go ahead and pause and cut out those numbers and come back when you're ready. Okay, now that you have all those numbers cut up, I put mine in like a bag here so I couldn't see what they are. I'm going to start with selection sort. I'm going to do each one of the sorts with cards first, and then I'm going to use the numbers. So I'm going to start with the selection sort. Maybe I could leave that on the screen somewhere. Selection sort. Okay, there we go. So I'm going to pick 5 cards since that's all that's going to fit on my document camera at once. I am shuffling them up diligently here. 1, 2, 3, 4, 5. Okay, so I've got my 5 cards. 1, 2, 3, 4, 5. Just barely fits on the screen there. And I've got some scissors here, which are kind of going to serve as the pointer for where I'm going to swap to next. So the first part here is finding the smallest card. So that's the selection part. Select and then swap, right? That's how selection works. So I look. Now, you and I know that 2 is going to be the smallest in this suit. I just use one suit of cards, but the computer doesn't. So then it starts the first one as the smallest, and it goes 2 and 6. Oh, 2 is smaller. 2 and 5. Oh, 2 is smaller. And notice I'm putting the cards back down because the computer can only compare 2 things at a time. 2 and 3, 2 is smaller, and 2 and 9, 2 is smaller. So 2 gets swapped to its spot. Oh, it's right where it already is supposed to be. Perfect. And then we'll do it the same way with the other cards. The pointer moves over because I'm not going to swap anything with this 2. The 2 is in its rightful spot. So then let's see, 6 is the smallest one currently in the unsorted portion. Oh, 5 is smaller than 6, so 5 is the smallest one here. 5 and 3. Oh, 3 is smaller than 5, so 3 is the smaller one. And notice that the scissors are pointing to where I'm going to swap to. 3 and 9. Oh, 3 is smaller, so 3 and whatever that element was, I don't really care what it was, swap. This moves over. And I do the process again. 5 is the current smallest card. Up, 5 is smaller than 6, so 5 is still the current smallest card. 5 and 9. Oh, 5 is the smallest card, so that stays where, well, technically it would swap with itself. Oh, it swaps into its rightful position, and then I do the same thing with the last 2. 6 is the smallest card. Oh, 6 is smaller than 9, so 6 swaps to where it's supposed to go, which is right there. And frankly, I could stop right then because I know that at that point, the last card is going to be where it's supposed to be because it's got to be the biggest card. So there you go. Those are all in sorted order. So the important thing with selection is the selection and then the swap. It's the only sort that does that swap. So select the smallest card, then swap it into its rightful spot. I'm going to switch to our next sort here, which is the insertion sort. So I'll try to put that up in the top left corner. I know some of you are like, why isn't Mr. Foster properly editing a video instead of using post-it notes? It's because I'm old, frankly. And that's just the way it is. So trying to shuffle some cards here for insertion sort. And maybe, okay, five cards. Is that too many? Maybe I'll do 5 cards. We can fit 5 cards in there. Okay, 5 cards. And the way the scissors are going to work this time is a little bit different. The scissors are going to show us the portion that is to the left. To the left of the scissors is the sorted portion. So you probably noticed in the insertion sort code that it started at index 1 instead of index 0. That's because a collection of one thing is sorted. This 9 is sorted. The rest of the cards to its right are not. So now I need to sort the next card to the right of the sorted portion. I want to add 5 to the sorted portion. And so what's going to happen is we compare 9 and 5, and 5 is smaller than 9, so 9 would shift over and 5 would take its spot. So that's important with the insertion sort. It's the shifting, the sorted portion and the shifting. Now the scissors kind of move over. Everything to the left of the scissors is sorted. So I take the next card to the right here. 8. And so what I kind of do is I go, how do 5 and 8 compare? Sorry, my hand's in the way there. How do 5 and 8 compare? Well, 5 is smaller than 8. So then I kind of move over to the next spot, and I go, how do 8 and 9 compare? Well, 8 is smaller than 9, so 9 will shift over to make room, and 8 goes in. And I move the scissors over. Everything to the left of the scissors is sorted. So these are all sorted here. I'll take the next one. 3. Okay, now there's going to be a lot of shifting in this one. So I take 3 and 5 and I compare them. 3 is obviously smaller than 5. So the way that the shifting has to work is, well, technically okay, so the way the shifting has to work here is 9 has to shift over to make room for 8, to make room for 5, and then 3 shifts into this position here. So those are all sorted, so the scissors move over one more spot, and then here's the last element that, oh, it's a 2. Okay, so I take 2 and I compare it, 2 and 3. 2 is smaller than 3, so the 9 has to shift, the 8 has to shift, the 5 has to shift, the 3 has to shift, and the 2 shifts into its rightful position there. And that is the insertion sort. So the important elements of the insertion sort that we're looking at are that you have a sorted portion. It probably starts at index 1 because we know that just one element by itself, the 0th index element, is already in its rightful spot. So there's a sorted portion that keeps getting larger, and that's shifting. I often compare it a lot of times to if you've ever moved before or put stuff back on a shelf, like you put a bunch of books into a box, you put one book on the new shelf, and then you take the next book and you go, does it go to the left, does it go to the right? And you put it in its rightful spot and stuff shifts out of the way, and you keep doing that one book at a time until they're all in alphabetical order, kind of like you're a librarian. So that's the insertion sort there. And then lastly, I'm going to try to demonstrate the merge sort. Now, how am I going to do this with cards? Maybe I'll do it with just 4 cards. Hold on one second. There's a lot to kind of demonstrate here with the merge sort. Okay. So there we go. Get them all out of order, kind of. Okay, that looks good. All right. So here's my merge sort with cards. So I've got 4 of them. I'm just going to do it with 4. That'll be easier. These 4, the merge sort kind of works. There's two processes. The first process is the split. So we start with 4 cards, and then we split that into 2 collections of 2. We cut it in half, and then we take each one of those kind of sub-arrays or sub-collections, and then we split those in half. So that's how it kind of works there. Now I'm going to focus on this half to start. And now that I've split them into halves, all the way down, you keep splitting it no matter how big your array or your array list, your collection is, you keep splitting it down until you've got sub-arrays of size 1. And then we look at them. And we kind of re-merge. This is the second part. There's the split and then the re-merge or the merging of those subarrays. So now I look at these. I look at the first element in each one of these subarrays, 8 and 2. The first element on the left is 8. The first element on the right is 2. And I go, which one is smaller? Oh, 2 is smaller. So so 2 would get copied, and then 8 would get copied over, and now they're their own sorted array. Now I look at the other 2 cards I had. Let's flip these over. 3 and 5. I compare the subarray on the left, first element, to the subarray on the right, its first element. 3 is smaller than 5, so I copy the 3 over, and then I copy the 5 over. And now those are sorted. Then, remember how I started with 4 cards? I kind of have this situation going on now. Remember, we split it into subarrays of index 1, then we remerged them into, subarrays of length 1. Now we have merged those, so now we have subarrays of length 2. I'm going to kind of do this to demonstrate this part. The subarray on the left and the subarray on the right. And I'm only concerned with like the top element in each one, or the first element in each subarray. And I look at them and I go, okay, 2 and 3. Which one is smaller? Well, obviously the 2 is smaller than the 3. So I take that and I'm going to copy it over into my merged array. Then I look at the top element in each one, 8 and 3. Oh, 3 is smaller, so I copy it over and remove it. Then I look at 5 and 8. Oh, 5 is smaller than 8. So I put the 5 there. And then since there's nothing left, I'm going to go ahead and copy everything else that's left in this array, which is only the 8. And I remerge that. And so in merge sort, we're going from an array of n size to size n divided by 2, and take that and divide it by 2, and take that and divide it by 2, until you get subarrays of length 1, and then we remerge them until we're back at n, the size that we started with. So it's the process of split, split, and then merge, merge, until we get back to a array length that we started with. And that is all of the sorts with cards. I'm going to do another video where I sort them a little bit faster using the numbers.